Alright, so we're going to actually derive the Pythagorean identity. So if we think about any angle that we have on the unit circle, so I've gone ahead and drawn one, we're going to call it theta. So here's my angle. We have our legs of the triangle and our hypotenuse. We know that the point right here is an xy. We can consider our hypotenuse to have a length of 1 because we know that it's from the unit circle, and we know that the x value of this point is going to be our cosine. So cosine of theta. We know that the y value is going to be the sine value. So for example, if I said we are going to look at, we'll do a 45-degree angle from the unit circle, we know the hypotenuse was 1, the x value is radical 2 over 2, the y value is radical 2 over 2. So if we wanted to find cosine of 45 degrees, we could use our simplified version and say radical 2 over 2. So we're going to go back. We know that the cosine is the x. Because we have a hypotenuse of 1, cosine is adjacent over hypotenuse, but since my hypotenuse is 1, it doesn't really matter. It's just your adjacent side. So now what we're going to do, if we think about the name, we have the Pythagorean identity. I'm just going to put identity, ID. The name itself tells us where it's coming from. So the Pythagorean identity comes from the Pythagorean theorem of a right triangle. So if we're using this right triangle I've just created, that means that a squared plus b squared has to equal c squared. Well, in this case, a and b are my legs, c is the hypotenuse. It happens every time. So 1 squared, a will be cosine squared of theta, sine squared of theta. That's just technical ways that we write it. We put the squared in between the cosine and the x or the theta. It doesn't matter. And this right here, cosine squared theta plus sine squared of theta equals 1 is your Pythagorean identity. So if you ever forget, think back to the unit circle. Legs squared plus legs squared equals hypotenuse squared.